And let's look a little bit more at standard deviation. So this is a picture of a normal distribution. And the standard deviation allows us to reach some conclusions about specific scores in the distribution. You can't see it as well down here, but if this right here is the mean, this dark blue line is the mean of all the scores, and actually it's written right here, the mean, then it's located at the very center of the normal distribution. And so these would all be scores underneath that curved line. And the standard deviation happens at these lines. This is +1 standard deviation at this blue line, -1 standard deviation at this blue line. This is -2 standard deviations, and this is +2 standard deviations. And at the very end, we have +3 standard deviations. And some nice percentages to remember right here. About 68% in a normal distribution, 68% of all the data will be between a positive standard deviation and a negative standard deviation from the mean. And we'll see what this means in a little bit. 95% of the scores will be within 2 standard deviations of the mean, both positive and negative. So that whole area under the curve. And 99% of all the scores will occur within 3 standard deviations of the mean. That's what symmetry in a normal distribution tells you. When the standard deviation goes down, that means that the mean is better at describing the scores for the group. As the standard deviation goes up, there's more variance. A large standard deviation would tell you that the mean is not very representative of the individual scores in the group. So I'm actually going to show you an equation for standard deviation, a measure of dispersion. So let's describe standard deviation in words. I'm showing you this equation because the textbook shows this equation. Voigt makes a point to talk about standard deviation because it's the basis of most of the other statistics that we're going to be using. So in words, you first determine the mean of your data set for one variable, and that's what that is, the mean. So you first have to figure that out, and remember that that's simply adding up all the values. So x1 plus x2 plus x3 and dividing by the number of values, which is n. That is the sample size, n. So the way to figure out standard deviation, you first have to figure out the mean for the variable. Subtract the mean from each score that you have. So the first one would be x1, then x2, then x3. Subtract that. This stands for squaring that difference. And then this sigma stands for a summation of all the squared differences divided by, again, the sample size, or the n. After all of that, you take this large symbol, stands for the square root of that amount, and that's your standard deviation. So sometimes, well, you can see that the standard deviation is built on the mean, and because the mean is susceptible to outliers, the standard deviation is susceptible to outliers too. But this is why this concept here, the squared difference from the mean, is used in other statistics that we're going to learn about too. The sum of the squares. The sum of the squares is used in ordinary least squares regression. It's fundamental to the general linear model, which we won't go into too much, but at least you will have heard that term. It's the heart of analysis of variance, another statistical technique that we're going to learn about in Module 10. And as I mentioned, it's critical for ordinary least squares regression, which we'll learn about in Module 13. The variance is simply standard deviation squared. The variance is roughly a mathematical average of the squared distance from the mean. Don't have to remember that, but it's another measure of dispersion, the variance. Okay, the third main descriptive statistic is distribution. And distribution is simply a summary of the frequency of the individual values in a variable. It's represented as a frequency distribution. The simplest distribution would list every single value of a variable and then the number of persons or subjects who had each of those values. So here is an example of a frequency distribution. And in this frequency distribution, you see this is the variable called enrollment status. And enrollment status has 1, 2, 3 values. A person or a subject, a student, could have less than 6 credits in the semester. They could have 6 to 11 credits in the semester, or they could have more than 11 credits in the semester. And the frequency distribution just tells us how many people that were enrolled had one of these values. 715 individuals had less than 6 credits. 1796 had 6 to 11 credits. 2172 had more than 11 credits. And our total sample size here, N, is 4,683 students. With this amount of information, you can also call this a percentage distribution because it's actually giving us percents as well. And so the percent is just the proportion of the entire amount in this that had this value. So that 715 students represents 15% of the total number of students, and so forth. This ends this part of the module's presentation. Please move on to review the next part